Time? It feels like the most constant thing in our universe. It's the metronome of our lives, ticking away the same for everyone, everywhere. We build our schedules on it, our history by it, but what if that's an illusion? What if the flow of time itself is not a river, but something more like fabric? And what if that fabric could be bent and stretched? Well, modern physics doesn't just suggest it, it proves it. And the force doing the bending is the most familiar one of all: gravity. Here's a thought that will bend your mind. Imagine two identical hyper-accurate clocks, one on the floor, one an inch higher. According to Einstein, the clock on the floor will tick ever so slightly slower. The reason? It's a fraction of an inch closer to Earth's center of gravity. Your head is literally aging faster than your feet. The difference is infinitesimally small, a fraction of a second over a lifetime. But it proves time is not absolute, it is personal. Your time depends on where you are and how you're moving. So how did we go from a brilliant thought experiment to confirming this incredible fact? Rockets, mountain climbs and clocks so precise they redefine the word tick. Our modern story starts in a state-of-the-art lab in 2022, GILA, a partnership of NIST and the University of Colorado Boulder. A team set out to test gravity's effect on time at the smallest scale ever attempted. They placed two of the most precise clocks ever built just 1 millimeter apart. The clock a millimeter closer to Earth ticked slower. Measurable, repeatable, time dilation on a fingernail scale. The lead scientist said this opens the way to clocks 50 times more precise. But GILA wasn't the first test. In 1959, Pound and Rebka performed a clever tower experiment at Harvard. They fired gamma rays upward inside Jefferson Tower to watch light fight gravity. As light climbed, it lost energy and shifted slightly toward red, precisely as Einstein predicted. This was a direct signature of time dilation verified in the lab. To get a clearer signal, you go higher. In 1976, NASA launched Gravity Probe A. They sent a hydrogen maser clock thousands of kilometers above Earth. The clock in weaker gravity ticked faster, about 1 second gained every 73 years. That tiny measured difference was a monumental triumph for relativity. From towers to rockets to tabletop labs, the signature of time bending keeps appearing. In 1971, Haffel and Keating strapped atomic clocks to commercial airliners and flew around the world. The experiment combined two effects: speed, special relativity, and altitude, general relativity. Eastward flights aged slower versus ground clocks. Westward flights aged differently, relativity in motion. It was a simple, elegant proof you can test with a plane ticket. And the proof sits in your pocket: GPS. Each satellite carries an atomic clock. Without relativistic corrections, your location would drift massively. Satellites are high, time runs faster, and moving fast, time runs slower. Engineers correct both effects constantly. Those corrections keep the system accurate. Without them, your GPS would be wrong by miles every day. So, what does this mean? It shatters a fundamental illusion. Time is not a single universal stream. Time is a dynamic, malleable field. Your time is your own, bent by gravity, by motion, by place. Clocks like those at GILA are becoming sensors, mapping underground structures, hunting dark matter, probing quantum gravity. The next time you glance at your watch, remember you're peering into a flexible fabric of reality, uniquely bent by your place in it. Thanks for watching.